A cosmic question. The universe is vast, really vast. It's a mind-boggling expanse that stretches beyond our comprehension. When we look up at the night sky, we are seeing just a tiny fraction of the stars in our own galaxy. Each twinkling light represents a distant sun, many of which are far larger and more powerful than our own. And there are billions of galaxies out there, each containing billions of stars. The sheer number of celestial bodies is staggering. Each galaxy contains billions of stars, and each star is a potential host for planets. Many of those stars have planets. These planets come in all shapes and sizes, some rocky, some gaseous, and some potentially habitable. Could some of those planets harbor life? This tantalizing question has intrigued scientists and dreamers alike for generations. The question of whether or not we are alone in the universe is one that has captivated humanity for centuries. From ancient philosophers to modern scientists, the quest to find life beyond Earth has been a driving force in our exploration of the cosmos. It is a question that has no easy answers. The vast distances and the limitations of our current technology make it a challenging puzzle to solve. But it is a question that we are now closer than ever to answering. Advances in technology and our understanding of the universe have brought us to the brink of discovery. We are living in a golden age of astronomy. New telescopes and spacecraft are revealing the universe in unprecedented detail, allowing us to peer deeper into space than ever before. New telescopes and spacecraft are revealing the universe in unprecedented detail. These instruments are our eyes and ears in the cosmos, capturing data that could one day answer the age-old question. We are discovering new planets all the time. Each new discovery brings us one step closer to finding a world that might host life. Some of them are eerily similar to our own. These Earth-like planets, with their potential for water and life-sustaining conditions, are prime candidates in our search for extraterrestrial life. The possibility of extraterrestrial life is no longer just the stuff of science fiction. It is a real possibility that scientists are actively investigating with rigorous methods and cutting-edge technology. It is a real possibility that scientists are actively investigating. They are analyzing data, searching for signals, and studying the conditions that might allow life to thrive. And the answer to this question, whatever it may be, will have profound implications for our understanding of the universe and our place in it. So, are we alone? The discovery of extraterrestrial life would be one of the most significant events in human history, reshaping our view of ourselves and our place in the cosmos. The answer is, we don't know. But the search for extraterrestrial life is one of the most exciting and important scientific endeavors of our time. It drives us to explore, to innovate, and to push the boundaries of our knowledge. But the search for extraterrestrial life is one of the most exciting and important scientific endeavors of our time. It is a quest that unites scientists across the globe, all working towards a common goal. And it is a search that is sure to yield amazing discoveries in the years to come. As we continue to explore the cosmos, we may one day find that we are not alone, and that realization will open a new chapter in the story of humanity. What is life? This question has intrigued humanity for centuries, sparking curiosity and wonder. It's a deceptively simple question, yet the answer is complex and multifaceted. We recognize life when we see it, whether it's the vibrant green of a forest or the intricate patterns of a coral reef. But defining it is tricky. Scientists have long debated the exact criteria that constitute life. At its core, life requires a few key ingredients. These ingredients are the foundation upon which all living organisms are built. These ingredients are the building blocks of all living things, from the smallest bacteria to the largest whales. They are the essential components that make life possible. First, we need the right elements. These elements are the fundamental building blocks of life. Carbon, hydrogen, oxygen, nitrogen. These are the basic ingredients for life as we know it. They form the molecules that make up our cells and tissues. They're also some of the most common elements in the universe. Stars forge these elements in their cores, scattering them far and wide when they explode as supernovas. Next, we need water. Water is essential for life as we know it. It acts as a solvent, allowing for chemical reactions to occur. Water is essential for life as we know it. It acts as a solvent, allowing for chemical reactions to occur. It also plays a crucial role in the structure and function of cells. It acts as a solvent, allowing for chemical reactions to occur. It also plays a role in transporting nutrients and removing waste products. Water is surprisingly common in the universe, often found as ice on comets and asteroids, and even in the atmospheres of some planets. Water is surprisingly common in the universe, often found as ice on comets and asteroids and even in the atmospheres of some planets. Finally, we need energy. Life needs energy to grow and reproduce. Energy is the driving force behind all biological processes. On Earth, the primary source of energy for life is the sun. The sun's energy fuels photosynthesis, which in turn supports the entire food chain. But life can also thrive in the absence of sunlight, using chemical energy from hydrothermal vents or geothermal activity. These environments host unique ecosystems that rely on chemosynthesis. The ingredients for life are out there. They are scattered throughout the universe, waiting to be discovered. They are scattered throughout the universe. This fact alone makes the search for extraterrestrial life all the more tantalizing. This fact alone makes the search for extraterrestrial life all the more tantalizing. It suggests that life, in some form, may not be as rare as we once thought. It suggests that life, in some form, may not be as rare as we once thought. The universe is vast and full of possibilities, and the search for life beyond Earth continues to inspire and captivate us. For centuries, our knowledge of planets was limited to our own solar system. We gazed at the night sky, wondering if there were other worlds out there, but we had no way to confirm their existence. But in recent decades, astronomers have developed incredible tools for detecting planets orbiting other stars, exoplanets. These advancements have opened up a new frontier in our quest to understand the universe. These tools are revolutionizing our understanding of planetary systems and the potential for life beyond Earth. The discovery of exoplanets has profound implications for our place in the cosmos. One of the most successful methods for finding exoplanets is the transit method. This technique has been instrumental in identifying thousands of exoplanets. When a planet passes in front of its star from our perspective, it causes a slight dip in the star's brightness. This tiny change can reveal a lot about the planet. By carefully measuring these dips, astronomers can infer the presence of a planet and even estimate its size and orbit. This method has been particularly effective in finding Earth-sized planets. Another powerful technique is the radial velocity method. This method complements the transit method and provides additional data about exoplanets. A planet's gravity tugs on its star, causing the star to wobble slightly. This wobble can be detected by observing changes in the star's light spectrum. Astronomers can detect this wobble by looking for shifts in the star's light spectrum. These shifts provide clues about the planet's mass and orbit. This method is particularly good at finding massive planets orbiting close to their stars. It has helped us discover many gas giants similar to Jupiter. The Kepler Space Telescope, launched in 2009, was a game-changer in the search for exoplanets. Its mission was to find Earth-sized planets in the habitable zones of their stars. Kepler used the transit method to discover thousands of exoplanet candidates, including many Earth-sized planets in the habitable zones of their stars. This was a monumental achievement in the field of astronomy. The discovery of so many exoplanets has been nothing short of astounding. It has expanded our understanding of the universe and our place within it. It has shown us that planets are incredibly diverse. Each new discovery adds to our knowledge and challenges our assumptions about planetary systems. Some are gas giants much larger than Jupiter. These massive planets have unique characteristics that intrigue scientists. Others are rocky worlds like Earth. These planets are of particular interest because they could potentially harbor life. And some orbit their stars in the habitable zone, where temperatures could allow for liquid water to exist on the surface. The presence of liquid water is a key factor in the search for life beyond Earth. Section 4. Life on the Edge. Extremophiles and the Limits of Biology. Life as we know it is remarkably adaptable. On Earth we find life thriving in the most extreme environments imaginable, from the frigid depths of the oceans to the boiling hot springs of Yellowstone National Park. These organisms, known as extremophiles, are pushing the boundaries of what we thought possible for life to endure. Take, for example, the tardigrades. These microscopic creatures, also known as water bears, are renowned for their resilience. They can survive extreme temperatures, radiation, dehydration, and even the vacuum of space. Their incredible hardiness suggests that life might be able to exist in environments far harsher than we once believed. Then, there are the organisms that thrive in deep-sea hydrothermal vents. These vents spew superheated water, rich in chemicals from the Earth's interior. Yet, despite the lack of sunlight, life flourishes here. Instead of relying on photosynthesis, these organisms have evolved to use chemosynthesis, deriving energy from chemical reactions. The existence of extremophiles on Earth challenges our assumptions about the requirements for life. It suggests that life may not need sunlight or even an oxygen-rich atmosphere to survive. This has profound implications for the search for extraterrestrial life, broadening the range of environments where we might find it. Section 5, the Goldilocks Zone and Beyond, Defining Habitable Worlds. When searching for life beyond Earth, astronomers often focus on planets located within the habitable zone of a star. This zone, also known as the Goldilocks Zone, is the region around a star where temperatures are just right, not too hot, not too cold, for liquid water to exist on the surface of a planet. Liquid water is considered essential for life as we know it. It acts as a solvent, allowing for the complex chemical reactions necessary for life to occur. Planets in the habitable zone are therefore considered prime candidates for hosting life. However, the habitable zone is not the only place where life might exist. Moons orbiting gas giants, for example, could potentially harbor life, even if they are located outside the habitable zone of their star. These moons could be heated internally by tidal forces from their host planet, allowing for liquid water to exist beneath their icy surfaces. Moreover, life may not always require liquid water to survive. Scientists are exploring the possibility of life forms that could exist in environments with different solvents, such as methane or ammonia. These alternative biochemistries could expand the possibilities for life beyond our current understanding.